Hello guys, so in this video we would be discussing some questions upon linked list. So my basic or the main aim for this video is that you get well versed with the concepts of linked list and how questions are asked in interviews. So let's get started. So first of all, we would be dealing with our first question is that to insert a node at the head of a linked list. Okay, so this is we are doing these questions upon HackerRank. So you could also make up an account on HackerRank as well, and you can solve questions regarding that. So if we see that there it is given a pointer to the head of the linked list, and we have to insert a node before the head pointer. So seems pretty easy. These are the sample input cases that we are given. Okay, and here is the explanation also, that initially the list was 383. After that we have added one more element, then added another, so our list keeps on growing. Okay, so after that, when this list is complete, we want to insert the new node at the beginning. So 321 gets added up here. Okay, so how to solve this question? Basically what it says is, see, we are given with a list. Okay, say that this is your predefined linked list. Okay, with node 0, node 1 and node 2. So what is your task? Your task is to create a node. Okay, set, let's say, node X. So you want that this node should be the head node, that means this. Okay, so how to do this? Basically, let's check this out. So here you can choose your language. So we are dealing in Java, so we would be doing only in Java. So see, the first case is that, see what is given. First of all, let us understand what it is saying. This is a method, that is main method, and there is code written, and we just have to complete this method of static singly linked list, and we have to insert the node at the head, and we have to return that node. Okay, and for our reference, we are given with a singly linked list node, and there is a int data and node next, as we have discussed in our previous video, that how to create a linked list. Okay, so let us first of all, we should always cover our edge cases. So what is our edge cases? See, if our L list is empty, that is null, so what to do? We would simply return this list. Else, while if our list is not null, see, we need to have a node. So I would be copying this, and singly linked list to add at head is equal to new singly linked list node and data, because this is the reference to the head pointer, as well as this data is to be entered in the beginning. Okay, so what to do now? We would do to add at head is equal to list, and list would be to add at head, and we would return this list. Okay, this was our program number 1. That is, we have to, what we have to insert a node at the head of the linked list. Okay, so moving on to the next program. See, now we have inserted the at head. Now we have to insert a node at the tail of the linked list. Okay, so see that we are given a pointer to the head node of a linked list and an integer to add at the end of the list. Okay, you can read upon this whole thing. This is our input format, and that how we have to take the input. This is our sample input, that 5 elements, so 1 2 3 4 and 5 elements, and after that we have to add the elements. So there is an explanation also for this also. So okay, let's get started with this also. So what needs to be done now? See, now we are with our list. Okay, edge cases we are now not taking into consideration just now, but in our program we would be taking into consideration. So let us assume that this is our list, already created list. Okay, and this is the new node that you have to enter. Okay, so next node of this would be null, simply because we have to enter it at the tail. So what we have to do, and this next is null, so we have to point this next to our new node, so that our entire list becomes this. Okay, so see, let's see how to write this. So basically first we have to get a reference. Basically I would first dealing with my edge case, that is, if head is null, we will return head, nor we would be creating a reference to our head node, because we need to preserve the address of the head node, so it is temp. So I would be doing while temp is not, no, temp dot next is not equal to null. See, why I have done this temp dot next? See, this is temp dot next, temp dot next, temp dot next, and we will go further on till our temp dot next is not null. Okay, because after that we have to insert this node. That's why we are going only till temp dot next. Okay, so see, if temp dot next is not equal to null, we would be doing temp is equal to temp dot next. Simple. Now the node that we have to create, so to add is equal to new node, no sorry, new singly linked list node, and this data. So now I would be doing temp dot next would be to add. Simple. And we would return head node, as simple as that. Okay, so this was our program to insert a element at the end of our list. Okay, so now we would be moving on to our next question, that is we are to print the elements of a linked list. Okay, so printing elements is easy, we have done in our last video also how to print elements. So see, this is the sample input and we have to show this output. So uh, printing list is easy. First of all, remember the edge cases. If head is null, we would return nothing. Else if it is not equal to null, first of all temp is equal to head, and while temp is not equal to null, we would be doing system dot out dot println temp dot data, and we would be doing temp is equal to temp dot next, temp dot next to go over to the next node of our linked list. So see how easy these questions are. Go and check upon these, how you could solve such type of other questions also. So these questions are very easy to implement. Okay, moving over to our last question, that is we have to print our linked list in reverse. Okay, so now what it is saying, it is saying that this, say for example this is our list, so we want to print this in reverse order. Okay, so let us see what is there in our function. Okay, we are giving in a singly linked list node class and a static void reverse print. So basically, what approach should we do to solve such type of questions? See, this is our list. Let us say only three elements, namely 1, 2 and 3. So we need to get 3, 2 and 1, and we are just given a pointer to the head node. Okay, so basically what approach that we can use here is that of stack data structure. So see, what does stack do? Stack is last in first out. Okay, last in first out. The element that comes in the last is the first to be removed. See, basically stack is like this. Okay, so first we would be entering here 1 would be going into the stack because now we don't have anything in the stack. After that, stack is that 0, then we would add 2, so 2 would come here, and then we would add 3, 3 would come here at position number 2. So what property of stack is there, that now we cannot access this one directly. First we have to remove the above two elements, that is 3 and 2. So we can do in such a way that first we would remove 3 and we would print 3. So now our 3 would be removed, then we would remove 2, 2 would be printed, and after that we would remove 1. So in this way we can satisfy our question. Okay, so let's see how to do this question. This is a quite uh, good question, so let's see how to do this. First of all, making a temp reference to head and checking the edge cases. Okay, now I would be making a stack of what? Stack of singly linked list node is equal to new stack. Okay, simple. So now we have created our stack. So what needs to be done is we need to add the elements to this stack. So while temp is not equal to null, I would be doing stack dot push temp dot data. Okay, getting my point. What I am doing is I am adding or pushing our temp, no, not temp dot data. I would be pushing this entire list, okay, or entire node, and I would be doing temp is equal to temp dot next. Okay, so our when this it would run till our temp becomes null. Okay, so now we have our method that while stack dot is empty. Okay, but we would run this loop till while our stack is not empty. So what we would be doing is uh, current item is equal to stack dot pop operation is to remove element from the top of the stack. So system dot out dot println current item dot data. Now we are just considered about our data. Okay, so this was our code for stack, for checking that or printing our entire list in reverse order. Okay, So I hope you understood this concept. So if if you understood all this concept, you could also try other questions that are there in regarding linked list also.